because some persons they look like them following them following on YouTube or some other place. So I have to make provisions for them. All right, so right now persons can follow us from Zoom, YouTube, or StreamYard, any one of the three. All right, so make we fix up this now, guys. So we're looking at, let's say, paper two style of questions, and so here we are. All right, so exam practice questions slash, well, it's a bit more paper 2. So yeah, so now remember that is next year on paper. You guys gonna do CXC. So next year is CXC year for you guys. How you feel about that? Uh, First of all, I don't have to get recommended. And let's be that in mind here. All right, so see what the question look like here. Everybody seeing this question?
Yes, sir.
All right, so usually now it's a table style of question. See if I can, if this can copy and drop in. All right. Yeah, there you go. All right, so I'm gonna send this to everybody. It's everybody in the class. So at least one of them can send it in the group. All right, so there's a question. All right, no. Does everybody understand the question so far? Does the question look like something that you can do?
Yes, sir.
All right. All right. This one is a yes. What about you, Chrisanti?
Yes, sir.
All right, then if that's the case, then what would your answer be for the first one? Table gives the composition of three particles, and you have particles A, B, and C, and the number of protons and neutrons are listed in a table. And A says, what is the evidence in the table for each of the following? So the evidence for one particle A is an atom. What's the evidence of that? How do we know that it's an atom?
Because the numbers of protons and neutrons, sir.
Yeah, number of protons and neutrons. Okay. Number of protons and neutrons. All right. All right. Let's hold on to that. What would you say? What do you say, Chrisanti?
Sir, because they represent elements on the periodic table, sir.
Well, they didn't say that. You can't say that. Nothing is said about periodic table here. Then just looking at what, based on what is shown, just focus on that alone. Don't take anything from outside of it. You are given a particle, given a letter name, and you are told that that particle has a certain number of protons, with a certain number of electrons, and a certain number of neutrons. However, the number of electrons are blank. So, and then hence the question here: what is the evidence in the table for each of the following? The particle A is an atom. So it's the evidence I want, really. So an atom must have particles in there, but you should know what those particles are, and they give you three of them, and then not only that, they should have particles. Then each atom has a specific number of particles. So, for example, this particle A, B, and C has a certain number of protons. All right. Now, suppose you were asked to say, okay, how many electrons would it have? Let's see, Max, give me your son.
15, sir.
It have 15. All right. So the key word here is atom. Let's go to this to answering this question here. The key word here is atom. All right. So you're saying 15. If it's an atom, number of electrons will also be 15. We could even go ahead and do this. So the evidence of an atom is that number of protons equal to number of electrons. That's the answer they are looking for. All right, neutrons. Well, you can actually have neutrons alone, because there are some atoms that don't have any neutrons. All right, anybody knows an atom that don't have any neutrons? In fact, there's only one atom that doesn't have a neutron. So an atom can exist without a neutron. Does anybody know the name of that atom?
Hydrogen, sir.
Yes, okay. Yes, O'Neill. Definitely it's hydrogen. So that's it. So hydrogen then, so therefore it is showing you, or it is actually telling you that atoms can exist without neutrons. So only thing we need now is protons and electrons to make up atoms. All right, and if it's an atom, the number of protons will always be equal to the number of electrons. Notice you say atom. All right, so one things you need to note here, that in an atom, the proton equal electron. In an atom, all right, number of proton is always equal to number of electron. All right, this is something that you can't forget. All right, and then now, and in you have another type of particle that is formed from an atom, where the atom will lose or gain electrons. Anybody remember the name of that particle? Name of that type of particle when an atom gains or lose electrons? Okay. Nobody knows that, so nobody has been revising. Well, that's okay. All right. So in an ion, the number of protons is not equal to the number of electrons. All right, so again, so atoms and ions are different. So I remember that. Remember the signs I'm using here. All right, the sign as usual means exactly equal to. So, and then of course this sign here means not equal to. So we're using the signs here. Any questions here, guys? All right. So now, no questions. All right. So from this, then, all right. Yes, you know what an atom is. Also, when you know what an atom is, be able to tell the difference between an atom and an ion. All right. You need an atom to form an ion. So an atom must first lose or gain electrons in order to become an ion. Because an ion now is when the number of protons and electrons are not equal. All right. Sometimes the electrons can be more, or sometimes the electrons can be less than the protons, but they can be the same for an ion. All right. And of course, the question is focusing on atoms. So know the difference there. All right. All right, guys. So let's move on. The answer for this for A is that yes, the evidence in the table for the following is that number of protons must be equal to number of electrons. Again, we fill in the electrons, and because it is an atom, we know that they will be equal. So that's it. All right. So A, B, and C are particles of the same element. They want evidence for that. What evidence is there for that? How we know what in the table tells us that A, B, and C are particles of the same element?
Same number of protons.
Very good. That's it. All right. No, not more than that. Everybody see that? All right. All have the same proton number. All right. Bam, that done. All right. So let's look at A part 3 now. Particles A and C are isotopes of the same element. So what evidence exists for that?
Sir, them have the same number of protons but different number of neutrons.
Excellent. No, not more than that. So that is the answer, guys. All right. So A and C are isotope because A and C is there. So A has 16 neutrons and C has 17. So okay, so for 2 marks you need to say same proton number, but what different number of neutrons. So all right, well done, students. All right, so we're doing well so far. All right, so part B now, guys. Part B is going into some more information here. What is the electronic structure of particle A? What is the electronic structure of particle A? All right. Do we understand this question? Understand the electronic structure? Particle A. All right. Do we know the atomic structure? Could we draw the atomic structure here?
Yes, sir.
Okay. And if you were to draw it, all right. So let's look at it. The question we asked: if you can draw the structure, how many electrons would particle A have? Very good. 15. All right. Where are the electrons found in an atom? In the shells. Good. So, and so can all of those 15 electrons be found on one shell? No.
No, sir.
Very good. So how will those 15 be arranged? If all 15 won't be on one shell, describe or explain to me how will those electrons be arranged?
Say 2 on the first shell and the rest on the other shells.
Okay, so let's start with 2. Draw one shell first, and then that will have 2. And then you're saying that this shell can't hold anymore. So we'll put the rest of them on this, which means that if you take away 2 from 15, that will leave 13. So can all 13 of them can hold on this shell?
No, sir.
Oh, so when do I stop drawing X's?
After 8, I'm sure.
After 8. So because 8 is on the second shell now, then we stop then. What 8 and 2 is just 10. So what about the others?
Draw one shell, sir.
Draw another shell. All right. And then now we end up with well, we have 10 so far, and it's 15, so maybe 5 can hold on this, and so that is it. All right. So fine. And so that's 15. I hope Christian, you understand how to do this, right?
Yes, sir.
All right, very good. And hopefully Tiana does, although I'm not hearing from her. But so then all right. So then but they didn't ask for the atomic structure. They specifically asked for the electron structure now. So electron structure is just asking us to look at the atomic structure and tell them how many electrons are on each shell. All right. So electronic structure tells us how many electrons are found on each shell. All right. And we start from the first to the last. So electronic structure, or electronic configuration. That's another name for it. All right. So this term here, in electronic configuration, is just simply asking how are these electrons shown? How are these electrons written? All right. So all right. So all right. So it's tells us how electrons are, how many are arranged. Yeah. On each shell. Yeah. About that. All right. So let's go to this diagram and see if we can answer that question. At electronic structure of A. All right. So on the first shell, what number would you write down?
2.
Very good. And then what we do, we use this to separate it. We can use to call this a semi. There's actually a colon. All right. And then the colon separate. The colon tells us that we're going to write the second shell, which has how many?
8.
Good. And then after that, now what remains? What's the next number after 8?
5.
All right. So this is actually the answer to the question. All right. The electronic structure of particle A is actually going to be 285. All right. Because the 15 proton that it has means that it has 15 electrons, and the 15 electrons are arranged so that the 2 go on the first shell, the second shell has 8, and the third shell has 5. All right. Hope everybody understands that. All right. And then the final part of this question would be, what is element A metal or non-metal? Give a reason for your choice. What would the answer be there?
Non-metal, sir.
You say non-metal. All right. Um, let's see. O'Neill, what would you say?
Non-metal, sir.
You say non-metal as well. All right. Tiana, if you can hear us, you can text in the chat. What would your answer be? Is element A a metal or non-metal? All right. So meanwhile, let's look at this. All right. So we want to confirm this then. All right, let me just ask though. Christianity, why did you say it's a non-metal? All right, so yeah. Why did you say non-metal, Christianity? Just a reason. I mean, because give a reason there. Metal or non-metal.
Sorry, the funny side where just them the funny periodic table.
Oh, that's a good point. It's a good point. It's a good point. It's over. You could say it's over the non-metal side, then. It's a very good point. Very interesting answer. O'Neill, what would your answer be?
So I was going to say the same thing, sir, and it's and because it's also found on the right side of the periodic table.
Oh, okay. I like those answers. I like those answers. All right. So well, Tiana gave her answer in the chat, but and Tiana would have said it's a metal. Wonder what would your reason be for putting it as a metal, Tiana? Should be interesting to see why you said it was a metal. No, up until this point, we are not confirming the answer, but the reasons really sound interesting. Sound really interesting. I really want to hear Tiana's reason, but some really solid answers though. All right, let's so let's have a look at the period table and confirm what you just said. All right, and all right, so let's use the images. All right, so I don't know if let's go. Here we are. Should be getting somewhere here. I like this. So we are going to as I really like the fact that you went on something we had learned before, and we did all this. Well, let's see what Tiana says. All right, so Tiana asking to repeat, but this time we're too late. All right. All right. So hope everybody's seeing this. And where would element 15 be? What's the symbol of the element 15?
P, sir.
P.
P, sir.
And P represents what? What does P stand for?
Phosphorus, sir.
Okay. All right. So Christianity, agree with that? P is for phosphorus, or is it potassium? All right, Tiana. All right, so Tiana, you can text the answer. But P definitely is for phosphorus, as O'Neill said. So this is actually phosphorus. So well done there, O'Neill. And so this is phosphorus. And if we identify this element, it's over on the non-metal side. So well done there. So that would be the answer. But then if you wrote that on an exam though, you probably you know that you wouldn't get the mark for it, you know. Even though you're correct, they want a better reason. It's what you want to say. All right, if you say right at the period table, let's look at the answers that because they actually release some answers that they would accept. And let's have a look at those. Where on earth is it? It was actually here a while ago. So they'll accept. They'll accept that it's found to the left of the periodic table. So, or rather to the right of the periodic table is non-metals. Let's go into this some detail here. Yes. So yeah, look at their answers here. Several answers they'll accept here. It's interesting, you know what they want here. They're actually gonna accept that because it has 5 electrons on the outer shell. All right. And left of the periodic table. And here's a rule now. If the element has most cases here, if the element has 5, 6, or 7, and 5, 6, 7, or 8 electrons on the outer shell, then they will all be considered non-metals. So that's another side to the story. All right. So then that's the answers they'll be looking for. The 3 answers they'll look for it. Well, one is that because it has 5 electrons on the outer shell, it will accept 3 more. So that's one of the answers. All right. And they also, because you could say it's because it is in group 5 of the periodic table, which is the 5th column. So and then of course they will also accept, being towards the right of the periodic table where metals move into non-metals. Those will be the answers they accept. So and so guys, as we say, with these CXC type questions, usually for paper 2 there are more than one answers for the question. For most, well, not for most, but for quite a few of them. So bear that in mind here, guys. So again, the correct answer here is that it's a non-metal. And then reason it is in group 5. It is in group 5 of the periodic table. And also you could say that it is found to the left, or to the right rather. Yeah, to the right, where non-metallic behavior increases. So yeah, so that's the answer. Found to the right of periodic table. Where non-metallic behavior increases. All right, so that's the answer they would be looking for here. All right. Any questions, guys?
No, sir.
All right. So was this question difficult?
No, sir, they only put in our way if he look difficult, sir.
Yeah, yeah. Well, get used to that, guys. That's how. That's definitely how CXC will do it. Let simple questions look challenging. But all right, so I'm gonna send this to you guys so that you can have access to the information and use it to get any practice or any revision you're doing out of the way there. Uh, so you should be seeing it in your WhatsApp. All right, I'm gonna try and I was gonna actually try and paste it. Yeah, I was going to try and paste it in in the classroom, but it's not working. This is something. Uh oh, okay. It's interesting. It looks like it yeah, but I can't get to do anything with it. All right. So yeah, all right. So you should get it in the chat. Now I'm trying to paste if the file, but it's not working. It's definitely not working in Google Classroom. So I can't do the same thing like in WhatsApp. So all right, guys. So this is where we're gonna leave it. Uh, so going
Yes,
with
sir, only two papers then give you, sir. Like
yeah,
the multiple choice and the long question part, sir.
yes, that's what they do. Two papers. Um, the other, well, technically three papers, but then the third paper is actually SB. So it's all the labs them that you do would add up to the to make up the third paper. So them have a thing where if you don't do any SBS, then you'll have to sign up for the third paper. So yeah, so that's the situation there, guys. All right. So any more questions? All right. Let me show you this though. I'm gonna give you this to practice with and because see the question two here, which might be a little bit different. So do this for next class. Because remember next class would be what Wednesday, but then on Wednesdays I am at Belfield as a face-to-face class up there with grade 11, and I remember that they set the timetable that way. So what I'm gonna do, I'm gonna send you the work right now for it. Um, so this is what should be done, and you can send it in the group. The students that say, "Sir, leave the work here." Um, for Wednesday's class. All right, so you should receive it. Um, for Wednesdays.
You really get this what, sir?
No, so you are gonna know for this what? I go say what? You can probably do this and Hannity as what? Let me for Wednesday's class. All right, let me just send this. So what you seeing on the screen there? Um,
Yes, sir.
mm, all right. Oh yes, Tiana is asking about the lab I sent. No, that lab no, it was a density lab. No, the problem with that lab, no, I wanted to do that lab. No, the problem with that lab is that it well, long story short, it used to could run in Google Chrome, but it's not working in Chrome now because what I was planning to do now was to send you the link so that you could go and do it there, and then all of a sudden it stopped work. So I'm trying to resolve it. And it's one of those virtual labs things. So until I resolve it, I can't go through with that lab. So All right, but I'll tell you more about that when we meet again. All right, let me see. All right, so I think you'd have gotten that message. Let me just send this to you, O'Neill. This is the assignment for next class. This is going to be part of your SWAT grade. I guess and also if I get the chance, so I'm going to I will say if do this and send this. Also I will try to send some multiple choice questions so that you can do it and you get the grade right away. And so I can just upload it into the um SMS support school from there. So I will try and work on that. But if not, this will be the SWAT grade. So just work on this one. It's what 12 marks. It's a value 12 marks. All right. So assignment for Wednesday's class.
Sir,
Yeah.
should I send this to your WhatsApp, sir, or do it send it take a picture and send it to your WhatsApp?
Yeah, man, do that.
Right, sir.
Yeah. So for Wednesday's class. All right. So everybody should have gotten this now. And as I say, you can send this in the group so to let them know. So this is the assignment that will be graded. All right. So yeah, that's it. Um. All right. So guys, thanks for coming out today, and enjoy the rest of your day. All right, and I'll see you guys next week. Uh, oh, you're saying that most of them leave the group. I don't know why they leave the group. Uh, anyway, it's anything there just the same because whoever stay will get it. All right. Yeah. All right. And so I'll see you guys next week.